start. Okay, so in here, how to determine the equation of a rational function given its key features. So we are dealing with number 58 in here, okay, and checking out what are the key features of such. So as you may notice in here, we're talking about what? Holes or removable discontinuities, if there are any. What else? Vertical asymptotes, if there are any vertical asymptotes. And also, what else? If there are x-intercepts as well. Get it? So let's figure out in here, looking at this graph, are there any of those key features for such? First of all, are there holes or removable discontinuities? Did you see any like hollow circles? No hollow circles, right? So I'll put in here, no removable discontinuities, right? Next one, did we notice any vertical asymptotes? And where are they? Madeline? -3, very good. So you see that vertical asymptote in here. Oops. X equals -3, right? And in here is at 4 as well, right? So there are two vertical asymptotes at -3 and 4 for x's. Get it? Are we good, guys? Okay. Next one. Do we have any x-intercepts for such? And if such, so where are they? Okay. Locate on the graph. Lexani, did you see any part of the graph that hits the x-axis, and what point will that be? Anyone? Emma? 3. Very good, right? You see that value? It's midway between 2 and 4, so we would say approximate it to be 3. Okay? So x equals 3 is the what? X-intercept. Okay, so we're going to use that one as well. And the last one, which I have not put in here. Well, I did, but I did not box. Y-intercept. Where did it hit the y-axis? So we're going to use that one as well, right? Adam, can you see any part of the graph that hits the y-axis? -2. Very good, right? So in here, let's color it green. That one, y equals -2, is the y-intercept. So again, we're going to use all of those 4. Okay, parts of the graph for determining the equation, right? Let's read our step number 1 first. Absalom, go ahead. Locate
holes and use x values.
Linear factorization.
Linear factorization to determine common factors up to down.
Up and down, all right? Thank you, right? So if there's a hole, then you use linear factorization theorem, right, to turn it into a factor. And that factor is a common factor between the numerator and the denominator. Are we good? But since there's no holes in here, that means there's no common factor up and down. Are we good? Right? Let's continue. Step number 2. All right? Let's read that one. Lexani, go ahead. Consider
the VAs and use linear factorization to determine other denominator factors.
Thank you, right. So the VAs determine the other denominators. Get it? So that's your BX, right? And what are the vertical asymptotes again a while ago? We said the vertical asymptotes happen at where? VA at x equals what again? -3, right? And also at x equals 4. So by linear factorization, what are the factors there? What do you do with that? X plus 3. Very good. And, right? Sign change, right? And here, x minus 4. So again, these are what? The denominator factors. Are we good? Get it, guys? Okay. Questions? Next one. Step number 3. Let's read step number 3 and how we can work on that one, okay? Giselle, go ahead. Spot
Spot the x-intercepts and use linear factorization to determine other numerator factors.
Thank you, right. So the x-intercepts are the numerator factors instead, right? So if the VAs are the denominators, the x-intercepts are the numerators, right? And what are the x-intercepts in here? Where did it hit the x-axis? 3, right? X equals 3. And with that being said, by linear factorization, then that means your AX, your numerator, will be what? Anyone? Adam? X equals 3, that will be what? X minus 3. There, right? That's correct. And again, that will be your numerator. Are we good, guys? Again, VAs correspond to denominators. X-intercepts correspond to numerators, right? Now what do we do after that, right? Step number 4. Let's read that one, right? Jaden, can you see it from there?
Multiply resulting expressions to A and solve this value using y-intercept.
Thank you, all right? So what's the resulting, right? So your numerator is what? X minus 3. Okay. Good. Your denominator is what again? X plus 3, X minus 4. Good, right? Now this resulting expression multiplied by what? A. Good, right? And equal to y. Right? And we're gonna solve that A using the y-intercept, right? So what's the y-intercept in here? What did we notice in here? It hits the y-axis at what value, Logan?
-2.
-2. So we're gonna use that one to solve for A, right? So that's it. Y-intercept -2 is equal to A. Definitely the x's in here will be gone, right? Because that's the value of y when those x's are zeros, right? So that means in here will just be what? -3 on top, and what in below? 3 and -4 multiplied together. Are we good, guys? Get it? Okay. And we're solving for A, right? So how do you solve for A in here? When we see a negative up and down, then that means they're gonna cancel out. What's gonna happen to the 3's? Hobbs, Christian?
They'll cancel out.
They'll cancel out, right? Okay. Now, you just want A, but there's a 4 on the denominator, right? How do you remove that A? And how do you remove that 4? Multiply, very good, right? So multiply both sides by 4. Get it? Okay. So this will cancel out. There we go. Hence, in here, A is equal to how much? That's 4 times -2. See the line? 4 times -8. There we go. Okay. We're almost done, right? Let's read step number 5. Okay, let's read step number 5 for such. Victor, go ahead.
Rewrite obtained function but solve a value and verify by graph.
Thank you, right? So what's our exact answer in here? That your f of x is equal to your a, which is what? -8. On top, it's what's again? X minus 3. And then below, we got what? X plus 3, X minus 4. Are we good? And last one, let's verify this by graph, okay? So I'm gonna graph it in decimals and see if we got the right graph, okay? So what's that again? Y is equal to -8, parenthesis, the numerator, X minus 3, okay? And then divide this by the denominator, where the vertical asymptotes are at, X plus 3. Once again, please recall our linear factorization theorem for that. Converting the X values to its factored form. Are we good? Is this the right graph? Well, let's see where the vertical asymptotes are at again. X equals what? -3. There we go. And X equals what? 4. Okay. Where the x-intercept at? 3, right? Where's that 3? We good? Right. Where the y-intercept at? Negative 2. We good? Questions? Also, as you may notice, that the horizontal asymptote actually happened at y equals 0, right? That's an additional fact for that, simply because, well, the degree above is less than the degree below. That's automatic. And verify, does it look, visually convincing from our graph? Are they the same? Yes, they are. Are we good, guys?